This is the brief on the orthogonality of tensor components in quadratic forms. So, we're diving into a really crucial principle in tensor algebra. It's essentially a powerful shortcut for separating a tensor into its symmetric and anti-symmetric parts. And doing this reveals some pretty deep insights, especially when you're calculating specific scalars known as quadratic forms. All right, let's break down how this works. First, you've got this core principle, orthogonality. This just means that when you contract a symmetric component of one tensor with an anti-symmetric component of another, the result is always, and I mean always, 0. They just don't mix. Second, this becomes super relevant when you start analyzing those quadratic forms. We're talking about that expression tab, va, vb, where you're calculating a single scalar value from a tensor and some vector. And finally, here's the real game changer. Because of that orthogonality we just mentioned, the quadratic form only depends on the symmetric part of the tensor. The anti-symmetric part, yeah, it's completely irrelevant to the final result, which just drastically simplifies the whole calculation. Ultimately, understanding tensor symmetry allows us to ignore half of the tensor information when calculating these essential quadratic forms.